Thank you. So we'll start the main wing design. We'll know what it is about. Okay. Meanwhile, where are you submitting your reports? You need more time. Today was supposed to be the due date, no? Any group needs more time for the wing estimation submission, for the weight estimation submission. Okay, otherwise you can submit today. Today is the due date. So send it to my email.
Yes, sir.
From the timestamp, I will know. If there's a delay of 1 day, 5 marks deducted. 2 days, 10 marks deducted, and so on and so forth. From what you get. Okay. So up to 12 midnight today, you can submit.
Okay, sir.
All groups are ready, no? The report, or any group is not ready? If you're not ready, I'll give you a little bit more time. That's why I'm asking. If you're ready, no problem. You can submit today. Okay, assume everyone is ready. So from the timestamp on the email, I will make out when you submit. Thank you. So Nick, you can start on the wing loading estimation if you're not already started. So what I need at the end of the wing loading report is, of course, the wing loading you are taking, W by S. So at the end of the wing loading session, we will have W by S. End of weight estimation, you have W. What if you divide weight by wing loading? What will you get, Sanjay Raghavendra? Sanjay Raghavendra, are you there? Status unknown. So, Bhuvandev,
Sir,
if you divide weight by wing loading, what will you get?
sir, weight by
Wing loading.
no, sir,
What is
don't.
wing loading? What is wing loading?
Wing loading is span by weight, sir.
No. W by S. S is wing area.
Sorry, sir.
W is weight. Weight by wing
Weight,
area.
W
Wing
by
planform area. Okay. So what will happen if you divide weight by wing loading? What will you get?
weight by wing loading, sir.
Hmm.
Yes, only, no, sir.
Yes, correct. So weight and weight get cancelled. So both the weight should be in same units. You have weight in kg and wing loading in Newton per meter squared, you will have wrong answer. You have weight in Newton and wing loading also in Newton per meter squared, then Newton will cancel. Okay.
Okay.
So that's how you get the wing area. How much planform area should your wing have? Okay, Bhuvandev. This is the starting point of wing design.
Okay, sir.
No. Now, so the wing loading report, as I mentioned, should contain what are the various phases pertaining to your aircraft. Combat wing loading may not be there for a civil aircraft. Okay, so you don't have to think of the wing loading. Whatever is given to you as constraints, you mark those constraints in red color. Whatever constraints you're putting yourself, I mean, even into the what are putting yourself from reference aircraft, you put those in green color. Green color means you can actually change those constraints if you want. Okay. So finally, put all the constraints in a single graph and choose a wing loading. Okay, I need all these things in the report. And even the constraints you get from FAR regulations and regulatory authorities should also be marked in red or orange. Okay. So, for example, first you mark them individually in different graphs. Suppose I have a takeoff length specified in my due to my either airport specification or takeoff length specification. I'll mark that in red. That is something which has to be fulfilled. Okay, that is, let's say, takeoff. What is x-axis? W by s. Y-axis is T by W. And suppose I have a regulatory, that is, for with one engine off, one engine inoperative, my climb rate during my climb rate should be at least 0.5%. That gives you something like this. Then that's a regulatory constraint. You can put in yellow or orange. Here I'm using yellow. This is, you can say, one engine inoperative climb rate. You may have many other things like that. Okay, all those you can put in different color. Then I have not been given cruise velocity. Suppose I choose my cruise velocity. Okay, then I say that my if I take this as my wing loading for cruise velocity, then the feasible region will be probably, I'm just telling probably this region. Or if I see that from comparison aircraft, no, I need to reduce the wing loading. What I can do is, this is green, so I can actually move. You can say, okay, average is here. This is from literature survey, but actually I want it. I don't want it here. I took it here initially, but I can adjust this, right? This is what I have given myself from reference aircraft. So I am probably to increase my. I want to bring the wing loading somewhere here. I'll put this as a cruise velocity. So all the right hand side becomes feasible. Just I'm giving an example. Okay. Don't take that. The graph may look different for you. So the adjustments you can do using the green line. Yellow and orange, don't touch them as far as possible, unless it's absolutely essential. Clear? Sanjay Raghavendra, are you there now?
Yes, sir. Yes, sir.
Is it clear?
Yes, sir.
Okay.
I'm sorry about the last time, sir. I couldn't
No
unmute
problem.
you. Yeah.
No problem. No problem. It's okay. Understand. So yeah, so much about the wing loading. Now let's move on to wing design. So this consists of all this, 6 steps. 4.7 and 4.8 are not really the steps. Okay. First, we'll choose the wing airfoil. Okay, or cross section shapers. You choose the wing airfoil. How to choose is the main. How will you choose the airfoil? So this is the main, first point you should do. You should remember that from weight you can get lift at cruise. Because lift is equal to weight at cruise. Usually, most of the aircraft will want their wing to be optimized for the airfoil to be optimized for cruise. Now, at cruise, before cruise and after cruise, the weight will be less. I mean, the weight will be different. Now, you calculate CL from these weights. You'll have a range of CLs. Okay, let's say when it has more weight, it has a CL of 0.5. When it has less weight, it has a CL of 0.45. So during cruise, CL can vary from 0.45 to 0.45. or 0.45 to 0.5. Now, if you want to optimize for cruise airfoil selection, you have to choose many airfoils. Then whatever you are getting in this weight is actually a 3D wings lift coefficient. For the 2D airfoil, it is the infinite wing should be had, but we can't afford infinite wing practically. So what we do is to make an approximation, we divide this CL by 0.9 to say that my airfoil should have that CL. So 3D wing will approximately have this CL. In other words, if the 3D, 3D CL is 0.45 to 0.5, then the 2D CL is 0.45 by 9, so 4.45 by 0.9 to 0.5 by 0.9, whatever that is. Now we get the CL for selecting a airfoil. An important criterion is the airfoil. If you look at, you can get all the airfoil data from many sources. Most important is Abbott and Von Duydenhoff. I might have shared the link with you or book with you. If not, I will tell you where to get it. Okay. So the book is called Theory of Wing Sections by Abbott and Von Duydenhoff. It is full of all airfoil data, the ancient one, 1940s data. Many of them are used even now. Or there are many sites, UIUC, which will give you low speed airfoil data. And there are some other things which have their own airfoil, which is not tested experimentally, but using some software tool they have tested. As far as possible, don't go for that airfoil because they are not tested extensively. But in the worst case, some of your designs may be very peculiar. And in that case, you can go for those airfoils. Or you can check out what are the airfoils used here, reference aircraft. So have some 4 or 5 airfoils taken from all kinds of sources. First one is CD naught should be minimum during cruise, or the drag bucket should be there within that CL by CD range. For example, you are getting the 2D CL range to be CL is say 0.5 to say 0.55. I told 0.45 to 0.5. I'm just increasing it a little bit for the 2D one. Then choose the airfoil in such a way that whether it is CL on x-axis and CD on y-axis, drag polar can be done either way, CL on y-axis and CD on x-axis, or the other way. Then this is suppose your drag bucket of the airfoil chosen should lie somewhere here. Number 1. This is airfoil 1. Airfoil 2 is somewhere here. This is not okay because in the cruise range this has more CA, more CD, right? Then airfoil 3, this is airfoil 2. Airfoil 3 may have the drag bucket here, but the CD is higher compared to even 2. So among these 3, if I have to choose between all 3, I'll choose 1. Okay. Or I have to choose only between 2 and 3. Then although the drag bucket is not here for 2, since the drag is actually less than 3 for this 2, I'll choose 2 as the second choice. If I have some other 4 which is here, in relation to 4, 3 has a lower drag, so I'll choose 3. Okay. So you compare for around 5 airfoils. 5 airfoils which is actually, you get from various sources. You don't have to choose the airfoil which is there in your, reference aircraft, not at all. You have 5 different airfoils and 5 different aircrafts. Yeah, then you can play with them and try. Clear? So this is how we choose the airfoil. If I have any doubts, you ask me now. All clear? Okay. Then second one will be taper ratio selection. Usually if nothing is there, you take it as 0.4. But if you want to, compare your compare with your reference aircrafts and choose it, that is also okay. Or you can have a mathematical way of an iterative way of choosing taper ratio and sweep angle in conjunction. Okay, we'll see how to do that. I'll tell you that. Then
Sir, I have a doubt.
yeah.
Sir,
Who's
when you
that?
say, yeah, Sanjay.
Sanjay, tell me.
Sir, when you say choose the airfoil, you mean we should design the airfoil using some airfoil design methods like thin airfoil theory or something?
No. You get the characteristics of existing airfoils. You can get the data for CL alpha curve. You can get it for CL by CD for these X-rays from the book which I told you. See, this is the
Yes.
book. I'll write the book here.
Okay.
Theory of this is one of the sources. Okay, you have airfoil.dat which have some theoretical airfoil.
Okay, sir.
But this is a good source. This is a good source. Okay, or from other sources also you can get some other later airfoil. These are the traditional ones. So author is Abbott, ABBOTT,
Okay, sir.
and Von Doinhoff. Okay,
Okay, sir.
it's HOFF. Okay, this is, okay. If you search in the Google, if you Google it, you will get a free copy. Okay,
Okay, sir.
it is available free of cost, free of copyright restrictions, anything.
Okay.
It is a NACA technical report, NACA, NACA technical report.
Okay.
So these people have done extensive internal testing on various airfoil shapes and recorded it. It's a classic data. You can take from here, or you can take from other sources, but mention whatever you do, you mention cite the sources properly in your report.
Sure, sir.
Unless absolutely necessary, don't go for airfoils which are not tested experimentally. There are many airfoils, a lot of airfoils available in airfoil.dat or some other websites,
Yes, sir.
which are tested only using X-foil or CFD. They never tested it experimentally.
Okay.
As far as possible, refrain from choosing such airfoils. And
Okay,
one
sir.
more, there are some low Reynolds number airfoils. Look at that is applicable only for very low speed aircraft. Check whether the Reynolds number is comparable to your aircraft. In case your Reynolds number is very low, that is below 10 power 6 is considered low Reynolds number.
Okay.
Reynolds number below 10 power 6 is considered low Reynolds number. For those Reynolds number, they have a special airfoils. One example is Epler airfoil for that. Epler. There are many other, but this is famous for low Reynolds number. So you have then in that case, if nothing is tested, then you can go for that computational or X file generated airfoil. Otherwise, as far as possible, choose the ones which are tested experimentally and data is available. as far as possible. That's
Okay,
my
sir.
request. Okay. So taper ratio, sweep angle is how do you. Then 3D lift coefficient. There is something to learn there. I will tell you how to calculate it. Because the lift curve slope is going to change. Basically, you will be calculating the 3D lift curve slope from the 2D lift curve slope of the airfoil which you choose. Which means the airfoil is actually assumes infinite wing. Because of the finite wing, the slope is going to be less. Okay, that's what it means. Then after that, very important thing, you have to estimate the wing drag. And even before that, 4 point is you planform geometric relations. If your wing area is fixed and taper ratio is fixed, then automatically sweep angle may be fixed. You may not be able to choose it. Then how do you choose these parameters? Okay, which one do you choose or which one do you sacrifice? All these things will be, say, wing planform geometry relations will tell you how they are. You want so much aspect ratio, so much area. Automatically a span is fixed. Okay. So this will tell. Actually, you can do it in conjunction with taper ratio and sweep angle selection, and then come to 3D coefficient, and finally you do the wing drag estimation. And though the order is like this, given like this, design the wing and then estimate the wing drag. So at the end of this exercise, I want something like this. So I want, import planform shape of your wing. I mean, very. For example, okay, planform. You can mention the leading edge also. You put the arrow. You can say free stream, or there is one way. Otherwise, I wouldn't know. Or you can just put here as LE. LE means leading edge. Okay. So what is this length? What is this length? And what is the leading edge angle? What is this angle? Sorry, that is not leading edge sweep. What is the leading edge sweep? Taper ratio I can get from the root chord and tip chord. All this data I want. Then I need the airfoil shape clearly plotted. Okay. So that I'll know the thickness and everything. You plot the airfoil shape. Then for the airfoil, you actually put, the CL versus alpha curve. How does it look like? Then this, CD versus CL curve. How it looks like. This is the airfoil. Then for the whole wing, also you plot the same thing. CL versus alpha and CD versus CL. These are the things. For the wing also you can plot. Actually, in the same thing you can plot. For the wing, probably it will look like this. I'm not sure. Or it may look even like this. When you compare with the airfoil, this is airfoil 2D. These may be, if you don't know, 3D may be something like this. In CD versus CL, sorry, it will look like this actually. This for airfoil. Then for the wing, how it looks like. This for the wing. First you show them separately, then show them the same graph. Okay. So I need this at the end of this exercise. You need to draw them correctly according to scale. Okay. Then the wing parameters we can list out. The wing parameters we'll see what they are. Yes. Now Naresh, have you shared anything with the class? Naresh? Pawan? Pawan?
Yes, sir. Hello, sir. Good morning.
Hi, good morning. You can share something with us today. Have you done it or you are going to do it? You are doing it already?
Sorry, sir.
Have you shared any of your
No, I have not.
thoughts? Yeah. You can do it today for our benefit.
Okay, so today is August 11th. A couple of days ago was Singapore's National Day. So
Yes, August 9th.
yes, sir, August 9th. So I was just reminiscing about my time in Singapore since I was born there and lived there for 13 years. I was thinking about the parade. There used to be this really grand parade every year. I don't think it really happened much this year, but
Why didn't it happen? Why didn't it happen this year?
I
Because of
think
COVID.
maybe because of COVID. I'm not sure if it did, but there's a lot of restrictions because of COVID. So I'm not very sure, sir. But I remember when I was young, we used to go attend these parades. It used to be really nice.
Yeah. Actually, I was also in Singapore for 12 years.
Oh,
So
okay, sir. Yeah.
I know that I got my PhD there. Then I was working there for
Yes, sir. Yes, sir.
so yeah. This is another in Raffles Place or City Hall. They'll have it. No?
Yes, sir. Yes, sir. And
Marina Bay. Marina Bay. They'll have
yes,
air show,
Marina Bay, yeah, Marina Bay.
air show and whatnot.
Yes, sir. Yeah.
During Chinese New Year, they'll have crackers there.
Yes,
You can't fire crackers in your home during Diwali.
yes, sir. Yeah.
Although people will smuggle crackers from Malaysia, and, suddenly they will.
Yeah,
Have you heard that?
I have heard of that. I haven't done that, but if you get caught, it's really bad.
No. I mean, I haven't done that, but
Uh,
I've
no,
heard
I'm saying this.
the noise in the early in the morning, some
Mm.
cracker noise. Some people, try to do that. Risk just for some small fun. They are risking a lot.
Yes, sir. I remember that. Yes.
Good.
So yeah.
Where do you study those 13 years? It's cool.
I was studying in an Indian school. I was in DPS first, Delhi Public School.
Okay. Is it
So
where is it in Serangoon Road or where?
it's in Kovan, sir, near Hougang.
Oh, okay.
Yeah.
Kovan or Kovin? Kovan, I think.
Kovan, it's Kovan.
Kovan. Yeah. Okay, great. Good to see a comrade. Okay, I can chat with you later.
Yes.
Are your parents still there or they are back in India?
No, my parents were there for 21 years. They're back here now. So,
Wow.
yeah.
Okay, good. Oh, 21 is longer than what I was. I was there.
Yes, sir. They went in 1995. Yeah.
Okay. I went in 91, but 90. I went in 90,
Okay.
not 1991. Then returned in 2004.
Okay. It must have been very different, sir, Singapore back then.
Yeah. I haven't gone back after that.
Yeah.
It's one way trip.
a lot of development has happened. So a lot of
Okay. Okay. Um, let's get back and if you don't mind, I have to supervise an exam at 9:30. So shall we wind up today and continue later?
Sure, sir.
Yeah, as I was told, 3 days